everyone, and welcome back. This is Dr. Diaz, and today we're diving a topic that shows up everywhere in your daily life. From the way your coffee dissolves in the morning to how medicine works in your body. We are talking about solubility. Solubility is all about understanding what dissolves, what doesn't, and why. It helps us predict whether a solid will disappear in water, whether a precipitate will form in a reaction, and how substances behave once they are mixed. In other words, solubility is the chemistry behind solutions, and the solutions are at the heart of so many natural and industrial processes. By the end of today's class, you will be able to explain why some ionic compounds dissolve easily while others stubbornly stay solid, how to use solubility rules to predict products, and how solubility connects to real chemical reactions. So here we're going to talk about solubility and how the solute dissolves. When a solute dissolves, the attractive force between solute particles and the solvent molecules must be strong enough to pull the solute apart. So here you see the solute-solute interaction. So between the atoms that form the compound, the solute, so the solid. And here is interaction between solvent solute interactions. So if the solute-solvent interactions are strong, if this here is stronger than this here, so the solute dissolves. Attractive force between adjacent molecules in the solid are solute-solute interaction. Attractive force between molecules in the solid and the molecules in the liquid are solvent-solute interactions. So water has uneven distribution of electrons. That means the electrons they are sharing here, for example, oxygen is sharing electrons with the hydrogen, right? So what happened actually here is that oxygen has the power to attract more electrons for its area because it has higher electronegativity. So what you're going to see actually is the electrons more in the area of the oxygen than in the hydrogen, and that will add will make the oxygen partially negative and the hydrogen partially positive. So that's why this is a polar molecule. This polarity allows water to interact with ions and dissolve many substances. So when sodium chloride dissolves in water, so water molecules surround each ion. And how this happens? So the sodium, which is positive charge, is attracted to the negative part of the oxygen over here in the water, while the chloride ion will be attracted to the hydrogen, which has a positive charge. So this process separates the ions and keeps them dispersed. So this freedom to move is what keeps them free and what is turned them a good conductor of electricity. So the solid sodium chloride dissolves as water molecules surround each ion. You can see here the positive ion surrounded by water molecules. Oxygen atoms of 6 water molecules surround individual sodium. So plus ions, and the hydrogen atoms of 7 water molecules surround individual chloride minus ion. So here, as I said before about conduct electricity or not, substances that form ions in solution and conduct electricity we call electrolytes. So ionic compounds, so they are good they conduct electricity really good because they form ions. Okay, so ionic compounds, like the example that we gave. I gave it to you, the sodium and the chloride, right? So substances that dissolve as molecule and don't form ions are known electrolytes. So like sugar. So they will dissolve as molecule. How that happens? So they are known electrolytes But what happened here is the sugar molecule will be surrounded by the water molecule. I'm gonna take you there. So, but before, let's go here. Strong electrolytes dissociate completely. Weak electrolytes dissociate only partially, like weak acids. So, strong acids like HCl will dissociate completely, will form ions and in aqueous solution. So when you add HCl in water, they will dissociate completely. But some compounds, for example acetic acid, they will not dissociate completely. So you can see over here that I'm gonna have some acetic acid, the whole molecule, and I'm gonna have some ions. Like you see the hydrogen over here, so and a part of the molecule over here forming positive and negative ions. They will conduct electricity, but in a very weak conduct of electricity. So again, the sugar, remember that I said I will get back there. So a sucrose molecule, a sugar, has a central chain of carbon atoms. So the black one here is the carbon atoms, the white is the hydrogen, and the red is the oxygen. So we have oxygen and the hydrogen atoms and the sugar molecule. Solvent interaction occurs between the hydrogen of sucrose and oxygen of the surrounding water molecules, and between the oxygen of sucrose and the hydrogen of the surrounding water. As you can see here pointing, all this are interactions, like small bonds that between hydrogen and oxygen. Okay, so and here you can see the sugar molecule surrounded by the water molecules. So remember that we talk about the acids when they are strong, when they're weak. So if they're strong, they conduct electricity. If they're weak, they will not conduct electricity as well, like the strong ones. So acids are molecular compounds that form ions when dissolved in water. Like we have strong acids, like hydrochloric acid, or we have weak acid, hydrofluoric acid. So what is the difference here? The difference is HCl, or hydrochloric acid, will dissociate completely. So we're going to see in the solution hydrogen ions and chloride ions. While the weak acid, like acetic acid, for example, you're going to see the whole molecule, and some will dissociate, like a small quantity of those will dissociate, forming ions. So strong electrolytes are substances that dissolve completely as ions. Ionic compounds and the strong acids, and they are good conductor of electricity. Weak electrolytes, they are substances that dissolve mostly as molecule but partially as ions. So weak acids and solutions will conduct electricity but not well as the strong electrolytes. So we have the non-electrolytes, molecular compounds that will not dissociate, like those sugar molecules. Weak electrolytes, like weak acids, like acetic acid, hydrofluoric acid, those will dissociate just partially, and the strong electrolytes as the strong acids and ionic compounds as sodium chloride. So let's test your understanding here. Which aqueous solution conducts electricity? So I will suggest to you to press stop in your video and try by yourself. So here what you need to look first is, okay, what do we have here? We have ionic compound, right? And here we have molecular compounds. So here, I know that for real, what we learn is that molecular compound, they are weak in terms of conduction electricity. However, some will produce electricity, will conduct electricity because they can partially ionize, but not as a strong acid or ionic compound. So in this case, the only ionic compound that I have here, and I know for sure that will conduct electricity, is the potassium bromide. That is our answer here. So the solubility of ionic compounds, when ionic is dissolved in water, the resulting solution contains not the intact ionic compound itself, but its component ions dissolved in water. And we saw that when you saw the sodium and the chloride dissociate in water. However, not all ionic compounds dissolve in water. In general, a compound is termed soluble if it dissolves in water, and no soluble if it does not. So, if we mix solid silver nitrate with water, it dissolves and forms a strong electrolyte solution, like you see over here. Nitrate and silver, they are separate, they are forming ions. Silver chloride, on the other hand, is almost completely no soluble. If you mix solid silver chloride with water, virtually all of it remains as solid within the liquid water, as you see over here. So when we will salt dissolves, whether a particular compound is soluble or non-soluble depends on several factors. Predicting whether a compound will dissolve in water is not easy. The best way to do is to conduct experiments to test whether a compound will dissolve in water or not. And then we can develop some rules based on those experimental results. We call this method the empirical method because we went there, we experiment, and then based on the results, we can write the rules. So we have the solubility rules here that help us predict whether an ionic compound will dissolve in water. Some ions like nitrate, acetate, or alkali metals as lithium, sodium, potassium, and also ammonium, they will always be soluble. There is no exception. However, some ions like chloride, bromide, and iodide, these ions will not be soluble if they are paired with silver, mercury, and lead. So in this case, the result will be a compound that is no soluble. Sulfate is soluble. However, if sulfate pairs with strontium, barium, lead, silver, or calcium, the resulting compound is non-soluble. So you will need to memorize these rules. So my advice here is that you know that those here are like nitrate, acetate, lithium, sodium, potassium, ammonium, they are always soluble. So then you focus on the remainings. And also hydroxyl and sulfur. There will be no soluble. And normally, those compounds with hydroxyl and sulfur are no soluble unless these ions pair with lithium, sodium, potassium, or ammonium. Or when sulfur pairs with calcium, strontium, or barium, the resulting compound is soluble. Or when hydroxyl pairs with calcium, strontium, or barium. So that means barium hydroxide will be soluble. So if I write down this barium hydroxide, so I know the hydroxide normally is not soluble. However, if it pairs with calcium or barium, will be soluble. Could be calcium as well. So I know these are soluble. So the same happens with the carbonate and phosphate. They are not soluble. However, if these ions pairs with lithium, sodium, potassium, or ammonium, they will be soluble. Okay, sodium carbonate, potassium carbonate, they will be soluble. So let's test your understanding. So the present one of the following ions with a compound indicates that a compound is soluble, with no exception. So just trying to remember what we just said is hydroxyl, we saw that we had some exceptions. sulfate, we saw as well that we have some exceptions. That normally they will not be soluble, but if they are bound with something, they will be. But nitrate, remember that I said, if you remember that nitrate is always soluble, that is the first step to memorize those solubility rules. So here, we saw that sulfate, we have some exceptions, because when it pairs with strong barium, lead, and silver or calcium, this will not be soluble. And we know the hydroxyl will be normally not soluble unless they are bound or pairs with some compounds. So in this case, nitrate is the one that is always soluble.